Now I can find super clear a vector in between the point. That vector. So when you have 2 points, we can find the vector. Suppose in that direction. So the direction is QP. QP, because QP is the arrow, no? It's a vector. I like using angular notation. And basically, is subtraction, no? Component by component. X1 minus X0, comma, Y1 minus Y0, comma, Z1 minus Z0. Let's see after the numerical example. No? Now, what's my goal? My goal is find that distance. Okay, D. Entonces es obvio que we can do that using projection. How? Well, D, no P, D is equal the projection. What kind of projection? Well, I suppose que horizontal projection. Why horizontal projection? Because this segment que I put in blue color is parallel to the normal vector, the only vector we have. So you're projecting QB vector in the direction of the normal vector, right? And give me the projection. So this is easy because I compute the unit vector and the direction of the normal vector. In this case would be normal vector divided by magnitude normal vector. And this is the unit vector and the direction of the normal vector. And you perform the dot plot. And you compute the horizontal projection. So it's easy. Let's do, for example, first of all, let's do QP vector dot product M. It's easy. Because M is ABC, ¿no? Entonces A times X1 minus X0 plus B times Y minus Y0 plus C times C1, this is 1, C1 minus C0. Of course, this is a scalar, right? Okay. Now, well, we multiply, you apply distributive property, no? It's AX1 minus AX0 plus BY1 minus BY0 plus CZ1 minus CZ0. Entonces I copy AX1 plus BY1 plus CC1, and this guy gets negative. This guy and this guy together is exactly the same of the equation of the plane, no? Entonces si I move, for example, no move, leave it like that, it's minus D, que es this element, D. Because the point X null, Y null, C null belong to the plane. They satisfy perfectly the equation of the plane. Just in case, I put actual value. And finally divided by M. Magnitude M, que magnitude N is square root A squared plus B squared plus C squared. End the story. This is the formula. The formula for D. Get the distance between point and plane. That's the formula. The student que want live formulas, okay, I respect. The student que no, entonces you are doing numerical. O sea, you select one point on the plane, que es super easy. No. No. You take the point is given in the problem, is x1, y1. So x0 no participate in the formula. You compute. Well, no, you can. See, you are doing that way, yes. But it's easy. It's easy. You determine one point on the plane. It's easy because, for example, this is z. Forgot z. Sorry. You assume x equals 0 to make easy. Y 0. This part disappear, and we have z equal d, no? And you solve for c, d over c, and you get a point that will be 0, 0, d over c. And you have a point q. You assume 0 because 0 is easy, but you suppose 1, 2, 1, 1. It's the same. But okay, guys. Either way, guys, formulas for a student que prefer formula or intuitions. Now, suppose the example. Example 1 of this part is the point is given. P is given. Is 4, negative 4, 3. This point is this point in the figure. Therefore, this is x1, y1, and 0. Okay, good. And the equation of the plane is given. It is 2x minus 2y plus 5z equal negative a. Okay, entonces now the normal vector associated with that plane is the vector 2, negative 2, 5. So you use on the formula, the formula is 2, que es 8, 2, que es 8, ABC, multiplication by 4, que es x1, a times x1 plus b, que es negative 2, multiplication by negative 4, que es y1, plus 5, que es c, multiplication by 3, minus d, que d es negative 8. Be careful because the formula have a minus, d is negative 8, entonces become plus. Absolute value is divided by, square root. Square root who? Square root 2 squared. Okay, 4 plus minus 2 squared is 4 again, plus 5 squared is 25. Okay, so in the top we have 39, and the bottom we have a square root 33. Now in decimal approximation, the answer is 6.789. Boom. Okay, no problema. Do you understand very well or no? It's easy or no? Yeah, it's easy. You don't need to memorize the formulas, no? You have in your notebook, and we're using anytime you want. Okay. Well, so no problem. We discussing now. How do you get
Professor?
81? 81. No, no 81. It's absolute value. Absolute value.
Hello?
Hello, wait. Don't interrupt me. Wait. It's 81, mister. No, it's 8. Who are you?
Yeah, I
Daniel.
was just gonna ask you if those points are gonna be given for the problem or
Yeah, and the problem is given, mister. It's
okay.
given 1 point. 1 point P is given. Look here. Given. And it's also given the equation of the plane. That's it. This is the only information. However, if you want to compute using that formula, in that formula we need 2 points, QP. You can find 1 point on the plane, que es super easy, que es the thing I explained or I try to explain here. You assume to arbitrary. Remember, in the equation of the plane, we have three variables. You assume x0, y0, and you solve for c, and you have the point. And this is the point key. I don't know if this answers your question or no. Yes or no, Daniel?
And how do we get n?
Good question. N is the normal vector of the plane, que es the coefficient 2, -2, and 5. Okay, 2, -2, and 5. So it's given implicit, no? Yeah, I am good now. Done. Okay. Okay, guys. See, you all lost one lectures. You can see or rewatching in YouTube. You need to be familiar with this new equation, new three-dimension object. Okay, now to plane. Distance between two planes. Distance between two planes. Two parallel planes. Es obvio que paralel, ¿no? Si the plane are no parallel, entonces intersecting, and when intersecting, the distance is 0, ¿no? It's obvious, right? However, si you suppose, you determine, or you investigate que the plane are parallel, and I want to explain how you investigate that. Super easy. You have two planes. Plane 1 and plane 2. And each plane have normal vector. Normal vector 2. In my paper, I call this guy different notation. This is 2 and this is 1. Entonces we have normal vector 2 and we have normal vector 1. And the equation for this plane is ax plus by plus cz equal d2. And the equation for this plane is similar. Well, not exactly. It's ax plus by plus cz equal d1. Actually, not necessarily the same coefficients, but proportional. Si es proportional, this is k constant. Because you determine that somehow the vector, the normal vector n2 is proportional to the vector n1. So if you multiply k times a1, so it's just scaling, multiplication by a number. You see in the example. Entonces normal vector in that case, Mr. one more time, is a, b, c, and normal vector number 1 is ka, kb, kb. And the fantastic way to prove that they are parallel is you divide component by component. You divide, for example, ka divided by a, you divide this guy, look, divided by this guy divided by this guy divided by this guy. And es obvio que es the same number as k. O sea, k, no, let me continue right color. It's good. K, you divide kb divided by b, and you divide kc divided by c, es obvio que es k. The answer. Entonces, you determine, wow, these vectors are parallel, the normal vector. Therefore, the plane P2 and P1 are also parallel. P2 parallel P1. Okay, so you select arbitrary totally arbitrary point on the plane that I want to call B, and another totally arbitrary point on the other plane that I want to call A. And as always happens, okay, this point is the point x2, y2, z2. And this point is the point x1. This I call it like that, x1, comma, z1. And using the 2 points, we can determine the famous vector in between 2 points. Suppose que I select that direction. Entonces es AB vector, ¿no? Okay, remember the convention always is the letter B is close to the arrow. It's because in the vector and geometrically is the arrow and the A is the tail. Okay, so now it's super easy to compute that. AB vector is subtraction x2 minus x1, comma, y2 minus y1, comma, c2 minus c1. That's a vector. That's the angular bracket. On the other hand, we have normal vector, ABC. But what normal vector you use? Either because they are parallel. So the only difference in between this normal vector is a constant. So you're using, for example, the normal vector can have a smaller number, right? Doesn't matter. So you perform the formula is AB multiplication by normal vector divided by magnitude normal vector, and it's give me the distance in between this plane. This is the same formula, guys, of the projection, horizontal projection. Remember, actually, the thing that we are doing is compute that distance, and that distance is the projection of the blue vector onto the normal vector direction. Okay, so now we have, well, you multiply this times this. That's the same rule of the dot product. Entonces, A times x2 minus x1 plus B times y2 minus y1 plus C times z2 minus z1. Of course, just in case, to make sure, I put the actual value, no? Because I want to guarantee that this is positive number, because we are compute distance divided by magnitude of the normal vector is a squared plus b squared plus c squared. It's similar analysis in the point and plane, but in this case it's two plane. When you are doing this operation, you apply distributive property and you separate, you understand very well that the top part is equal d2 minus d1, because A and B are the point on the plane, no? Entonces now, in this equation, when you plug in 1, 1, 1 is d1. When you plug in here 2, 2, 2 is d2. So basic, you distribute it, separate the part that contains 2 and the part that contains 1. And the formula is super easy. It's absolute value d2 minus d1 divided by square root a squared plus b squared plus c squared. I'm making sense, right? Because d is the right-hand side number in the equation of the plane, que represents somehow the translation of the plane. So this plane have the same normal vector, they are parallel, but the difference is they are not coincident because D is different. Okay, so you subtracting the D, so somehow give me information how separate is this plane. Okay, let's see example. Do you understand the basic idea? It's the same, a similar idea of the example 2 now. In example 2, we have a plane, two plane. 3x plus y minus 4c equal 2. Entonces you can see clear que the normal vector is 3, 1, -4. Okay, coefficients, these coefficients, okay, is invisible 1 and -4. And the second plane, wow, not necessarily it's always like that, too easy, but it's the same. But the difference is que now is not 2, it's 22. It's the same normal vector for both planes. Entonces es obvio que they are parallel. Pero no necessarily it's the same, they are proportionally. Suppose que I might change. I put 6 here, 2, and 8 equal 44. I have the same plane because the only thing I did was multiplication by 2. The entire equation of the second plane is a plane 1. This is plane 2. And this plane 2 also is the same plane because these equations are completely dependent. It's the same thing, right? You know very well in algebra. En linear algebra o en precalculus. Okay, ready. Entonces, plug it in. Plug it in where? In the formula. The formula is capital D is equal to absolute value 22 minus 2. Doesn't matter who is D1, D2. Or you put 22 minus 2 or 2 minus 22, but when you find the actual value, 20. Divided by the square root of the normal vector. Magnitude is 3 squared plus 1 squared plus -4 squared. Okay, this is 20 divided by something, divided by radical 26. And this is approximate to have some idea geometrically how far is this plane is 4.31 approximately, you know. End story. Super easy. Distance between two planes and distance between plane and point. Any question, guys? You follow? Look like complicated this one? No? I predict that this is super hard. Not exactly like this part, in general. Say something, guys. Any feedback? You follow me? Everything okay or no? Because I want to discuss it, David. I want to discuss it. David say yes, okay. Now finally, plane and line relationship. I follow. Plane and line. So we have a plane. Suppose 3 plane. And lines. Relationship. Line. For the line, let me use in red color. Then we have this kind in which the line touch and continue. This is a Zika case. Zika. We have another possibility is that the line is completely parallel to the plane and never touch the plane. This is parallel. And the last possibility is containing. So they are perfect coincident. And between the plane and the line. Now, see, we are talking about distance. The distance is 0. The distance is this. But it's relatively easy to find this because you select one point on the line and you apply the formula that we studied before, the distance between the point and the plane. You want to find it. Distance here is 0 porque touch. Distance here is 0 because contain. Entonces, how you differentiate? Well, you differentiate because Or in any case, you have normal vector of the plane. Normal vector. And if you perform the dot product between the normal vector and the direction vector of the line, look, direction vector is a vector here in that direction, B. B is in that direction or in that direction. It doesn't matter, the direction is not important. You perform the dot product, in this case is 0 because they are perpendicular, right? However, in this case, no. In this case, the normal vector and the dot product, and between the normal vector and direction vector of the line. So B is the direction vector of the line. And M is the normal vector of the plane. Es no zero. You detecting que sí can parallel coincident if you perform a dot product and the answer is 2. Entonces sí. The answer is 0, entonces maybe it's parallel or containing. How you differentiate that? It's easy, super easy, straightforward. Because, for example, you have in your hand the parametric equation of the line, and you plug it in. We did before this parametric equation into substitution, plugging in into the equation of the plane. Entonces maybe sometimes happen that you have a linear equation when the one unknown, suppose a stupid example, 2t plus 3 equals 5. Now when you plug in the parametric equation of the line inside the equation of the plane, you get one equation that contains the variable t, que es the parameter, and you have solution, que es suppose 1. This is a hypothetical example, guys. Hypothetical. In few seconds, you see actual example. Now, you detecting que es parallel, see you get this equation, for example, 2t plus 3 equal to t plus 5. Wow, what the hell? This is contradiction, right? This is no solution. No solution. If si es no solution, obviously, it's parallel because we have no common point. And containing, well, you take 2t plus 3 equal to t plus 3. Wow, so in this case, we have infinity many solutions. 0 equals 0, no? Because it's perfect coincidence, 100%. So any point on the line and on the plane coincident. There are no common point here, and you have only one point, get this. This is classical. Intermediate algebra, elementary, linear equation. Using one variable, we have 3 cases. The standard case, because we have one solution. Okay, nice. It's because it's in the specific problem that we are discussing now, the intersection between line and plane. No intersection, no solution. Infinity many solution is because containing. That's it. Let's see example to clarify this idea. Look, suppose que is given an example 3, no? Today. Suppose que is given the parametric equation of the line. Remember the representation of the line is in parametric. No? The equation, this is the set of the parametric equation for the line. This is the line. Don't forget to define the domain of T is in general a subset of the odd real number. In this case, no, it's an odd real number because it's a line. It's infinity in both directions. Okay, now we have equation of the plane. Plane. And the plane is giving also the equation is 2x plus y plus 3z equal 5. Well, it's super easy, guys. The only thing you should do is substitution. This expression and x here. This expression and y. And this expression, okay, actually is just 3. I don't know why, but it's giving the problem. No, I respect this. And to say you plug in it. Let's do it. It's super easy. You find 2 times -1 plus t plus y. Y is 1 plus t plus 3 times 3. It's a coincidence. It's 3 and 3 equal 5. One, okay, you have linear equation, super easy. You apply distributive property -2 plus 2t plus 1 plus t plus 9 equal 5. Combine like term is 3t. This and this together. And this is 8, no? Because it's 10 -2 is 8 plus 8 equal 5. And 3t is equal 5 minus 8 is -3. 3t is equal -3 divided by 3 both sides. T is -1. Okay, and that's it. No, this is the beginning. Now I want to determine the point in which this line and this plane intersect, touch. But it's super easy. For example, you're plugging in 1 by 1 t equal -1 in the original no, the parametric equation of the line. So x is equal -1 plus -1 is -2, no? Y is +1 plus -1 is 0. Is 0. And C is 3 because C do not depending of T. Okay, this is the problem. Okay, this is the famous point que I'm looking for. Let me call Q is the point -2, 0, 3. Okay, this is the point in which, look, my plane, and my line, boom, touch. Okay, this point is this point. Curiosity. Just curiosity. This point belong to the line and belong to the plane. So if you plug in this value, -2, 0, and 3, and the equation of the plane, I suppose you get true statement. Let me try. It's 2 times -2 plus 0, get y, plus 3 times 3, should be 5. Okay, I put a question mark because I don't know if this statement is true or false. This is -4, this is 9, equal 5, 5 equal 5. Super. Do you understand very well? A ver, opinion. Right in the chat. Teo dice yes, I understand. Okay. But I want discussing with you now. But you're thinking quickly. No. Suppose now, okay, I want, let me see one more elegant sketch. The situation that we have is the plane. Thinking. Okay, it's the plane. We have the line and we discover the point. Bam. My goal now is I try to investigate this angle. I want to call theta. Okay, let me try to see the lateral view. This is my eyes, look. In the lateral view, I saw the plane like a line. Here the line is a line. And touch in this famous point Q, no? It's a Q point. Yeah, I need to find that angle that I want to call theta. Okay, super. What should I do? Normally in 3-dimensional geometry, when you try to find angle between the vector, I say something I don't say. So you want to find the angle, what operation you should do? angle in between something. Come on, guys. Tell me. What vector I have in my hand? What vector I have in that problem? Well, you have normal vector, no? Okay, normal vector is 2, 1, 3. Everyone follow me? In the plane, no? And direction vector, who is direction vector? B. Direction vector is the vector in the line, no? This vector. Doesn't matter if it's over or downward, I don't care. Is, go ahead. Activate the microphone. Help me, I need help. I am lost. It's 1, 1, 0, no? Look at that. 1, 1, and 0, because we have no t here, 0 t. Okay, this is direction vector, negative 1, 1, 3 is a point. Remember, the information that we need to define the line is a point and direction vector. This is direction vector. Super. Entonces now, I don't know if you remember or no, the formula to find the angle, no? So you have that vector. All right, let me try. Erase this cube. You have the normal vector que you put in any position, suppose here. And you have direction vector, que es this. B. Entonces, the formula that we studied in the first day, yeah, in the second, in the first day, is the in this case we found that angle. I want to call alpha. So alpha is equal cosine inverse of the dot product, normal vector, dot product B. Remember, the dot product is totally commutative. I don't care if you put B multiplication by n or n multiplication by divided by magnitude m multiplication magnitude b. This is a regular multiplication. And he said, no, this is a special dot product, no? This is alpha. And theta is obvious que es 90 degrees because they are complementary, no? Alpha and theta are complementary minus alpha. End of story. Do you remember this or no? So now let's do in the dot product. Dot product M, dot product B. Okay, remember dot product is super easy. Dot product is multiplication component by component. You multiply this times this, this times this, and this times this. Es obvio que es 2 times 1 is 2, plus 1 times 1 is 1, plus 3 times 0 is 0. Es 3. Dot product is 3. That number is 3. And magnitude, the normal vector is square root. 2 squared get 4, 1 squared get 1, and 3 squared get 9. And this is square root 14. And magnitude direction vector of the line is square root 1 squared plus 1 squared plus 0 squared. It's radical 2. Put together, everything together. Entonces es alfa, que es the cosine inverse of 3 over radical 28. Because radical 14 and radical 8 together is radical 28. By the way, it's a simplification because you know 28 is 7 and 4. Yeah, I know very well that 4 is square root, 4 is 2. Is cosine inverse of 3 over 2 radical 7. Then put the calculator, and that's it. This is 55.46 degrees, but this is alpha. Entonces I need theta, pero theta is 90 minus this. And the answer is 34.54 degrees. This information is more accuracy because you investigate at what point the line and the plane touch. Y I investigate also at what angle incident this line onto the plane. Okay. Also, no problema. Do you understand very well? Totally confusing. I don't understand anything. No. It's no good for me. Okay, clear. Okay. Guys, you have to practice. Of course, you take advantage the tutoring. You know, I asked to Jose Alegre, and nobody go to see Jose Alegre. And yesterday I spent all the time in the lab virtual, and no student of Calculus 3 is coming here to ask me any question. However, another student in Calculus 1, yes. Okay, super. Okay, now surface. This is the most important moment, crucial moment in this chapter, because we need to understand very well surface. Not only for the chapter 1, you know, the chapter 2 and chapter 3, fundamental chapter 3. Okay, let me try to find the one PowerPoint. Do you see that I sent to you in the email that I sent the link for this lecture? I sent the PowerPoint. Do you see now? It's the same. Yeah. It's the same PowerPoint. I want to show you now. Okay, my intention now. This is too long process to understand this and memorize this. My intention now is, introduce to the surface and cylinders. And I promise that after, when you are a little bit familiar with the name, the shape of this new surface, now I discuss it in detail, not necessarily finish today, that part. Okay, look. Let me start for the cylinder. This is the first slider. So when you hear about cylinder, everyone believes que es a circular cylinder. No, not necessary. Not necessary, guys. A cylinder is, first of all, this surface that we are studying now, normally the name is quadric. What is the reason it's quadric? Because, okay, it's important, guys, that you understand the difference between, for example, we study plane. In the plane, everything is linear. What means linear? Que the exponent is 1. That is the reason that the plane is flat. Okay? And the line, it's confusing because the line, is parametric equation. Okay? But now we study some surface. So the technical name is surface, no? A surface, remember, surface is two-dimensional object, no? Because it's only the area, surface area, no? It's the peel, the area outside the figure, no solid 3D object. Of course, this surface is living in the three-dimensional space, no? But the reason the surface is because the exponent now is 2 or 3. We have infinity possibility. However, we study in detail the quadric. Quadric is when the exponent is 2, x to the second, y to the second, and so on. But I need to differentiate surface in 2. Cylinder and actually surface. Let's see, cylinder is a special surface in which one variable is missing. You see, one variable is missing in automatic a cylinder. Bang! Suppose this example is, let me make it zoom to see more clear. is this is taking for the algebra, no? I take the picture, no? Take the picture, no? No, using camera, no? You put in the algebra, share like an image, no? Entonces this is x squared plus y squared. Entonces, you know, the three variables that we have in any problem in three dimensions is x, y, and z. Entonces es obvio que z is missing. Z is missing. See, I asked you, what is this figure? Well, this figure in 2D is a circle. X, Y is a circle. You know very well, no? But in 3D, no, because C is missing. Therefore, the Z-axis, by the way, is the blue color. You assume, si C is missing, you assume que es a real number. Therefore, this axis, que es the Z-axis, que es perpendicular to the Y bar, is cylinder. It's extending forever out the board and in the board in any direction. Do you understand the idea? Do you understand the idea? Cylinder? However, Emiliano, not always circular cylinder. For example, in this example, you have y equal c squared. X is missing. Therefore, this is a parabola. So you are doing, for example, this is important, guys, super important. To see a view. I want to explain detail view or traces. Suppose que given this equation, I need to analyze. Immediately say, well, no, in 3D, this is a cylinder. How do you know that? Because X is missing. So we have, for example, this is the y-axis and this is the z-axis. We can know because the x-axis is here, perpendicular to the y bar. I know very well. I know very well. Okay, this is the, let me see, y equal, this is the parabola like that, right? Like that. Like that. Yeah, like that. You see? This is precalculus. In precalculus, we study, for example, in this case, x equal 4p y squared, right? Because I suppose it's confusing. Why? What is the? In this case, I suppose que in the horizontal axis, I suppose y, because x-axis is missing, is perpendicular to the y bar. Okay, entonces this is a parabola. It's a parabola and P is positive and open to the right. Okay, now you see that this is also cylinder, pero parabolic cylinder, parabolic. This is circular cylinder and this is parabolic cylinder. Super? Super? I promise que we study more cylinder. But this is the base idea. Everyone follow me? Now, I have another family of surface, more complicated, more interesting. Suppose this. Suppose ellipsoid. Ellipsoid look like the football ball. And how we identify ellipsoid? Look at the equation. Let me try to separate this. A cylinder, you understand, no? I suppose. Now let me separate ellipsoid. In ellipsoid, when you see the equation, this is different example. I promise I want to explain in detail. Now, today is nice to meet you. Okay? You get the hand, nice to meet you. I am familiar with the name and the shape and the equation a little bit. When you have x squared, one number, x squared, plus another number, y squared, plus another number, z squared. So when the all variable are present, all variable are present. But at the right hand side, you put the number, right? This is arbitrary number, 4, 20, 40, 60. After I want to explain how you organize in the elegant way. But the most important is all variable is present. No more variable is missing, no. See, missing a cylinder. See, all variable is present, and all are r squared, and all are squared. Therefore, es elipsoide. It doesn't matter que es expressed in standard or no standard. I suppose you are familiar with this idea in pre-calculus when the right hand side is 1. But I want to explain in detail you more. Entonces, copy this, please. Ellipsoid, how you identification. When the all variables are present, no omission, no. And every variable is squared. This is ellipsoid. This is the most important idea in ellipsoid. Okay, good or no? And look like football. Entonces, how do you know, professor? And what axis is bigger? What is the major axis? Well, depends on the number, right? Depends on the number. But I promise I explain in detail after. Only shape, name, and equation, and identification, relationship between these three things. Clear or no? Ellipsoid is okay? Okay. Now, let me erase that part. So we are discussing surface. No cylinder. Surface in which any variable is present. Cylinder, no. Cylinder is when the one variable is missing. And then we have another kind of the quadric surface, que is, for example, let me explain in detail. Wow, this guy. A ver, this guy. Okay, we have hyperboloid of the one sheet and hyperboloid of the two sheet. This is a family because the similar name, no? Hyperboloid one sheet and hyperboloid two sheet. And by the way, why not cone? This is very, very similar equation. I want to explain in detail now. Guys, I dedicate time to this. Therefore, I expect you, when I put the equation, you immediately recognize this equation corresponding with the cone, or this equation corresponding with the ellipsoid. Okay? What is the common part in between these figures? Well, I suppose you remember in pre-calculus hyperbola. Hyperbola is a quadrant. The conic section can look like that. Okay. Conic hyperbola. Well, the equation of the hyperbola in standard, of course, is x squared over a squared minus y squared over b squared equal 1. In this case, the supposition is that the transversal axis lie in the x-axis. This is analysis 2D. This is x-axis, this is y-axis. Okay? And this is look like similar to this, not exactly this and not exactly this. Entonces, suppose que you have one equation in which this number is a square. This is also a square. And this is also a square. Wow, this is the same. And we have the number. But in this case, in the ellipsoid, this number is positive. And this is positive, and this is positive, and this is positive. In this case, no. In this case, suppose get the right hand side. Suppose get the right hand side. Okay, this is the right hand side. Suppose que the right hand side es positive. Ok, entonces el elipsoide. Okay, we saw it before. Suppose que the right hand side es negative. Pero I forgot to say something. Sorry. Suppose que in this case, the 3 are positive in the ellipsoid. Suppose in the second equation, 2 are positive. So at least one negative, no? Entonces, si this number is negative, when you multiply, when you manipulate, of course, and multiply by -1, then see we have 2 positive and you multiply by or divide by -1, so this positive becomes negative and the other case negative becomes positive, no? So you change. So since the right hand side is negative, we have hyperboloid 2g. Okay, hyperboloid 2g is this guy. Okay. However, see the right hand side is negative. Is positive, sorry. And under the supposition que one guy here is negative, entonces hyperboloid 1g. Okay, maybe I complicate too much the explanation. It's super easy, look. Suppose que 1 is negative and the coefficients x, y, and z. Entonces hyperboloid 1g. Suppose que 2 negative, hyperboloid 2g. Suppose que everything is positive, ellipsoid. End the story. And suppose que right hand side is 0. Ese con, like that. Ese con. Exactly the same equation, but the behavior is determined by the amount of negative number, and the right hand side is also 0, no? Also 0. Okay. One negative. And okay, do you understand very well? No, let's see example, Anna, you understand. But let me present everything together. Now, one more clear. One more. We have a paraboloid. Ooh, this is important. Paraboloid. Paraboloid. Paraboloid equation is different. Is look. Suppose one number x squared plus one number y squared plus or minus, depende de the direction que open the paraboloid, one number z equals 0. Okay, 2 square and z no square. Not always happen this situation. This is the paraboloid, it's the name because it's a parabola. But in 3D, no? However, when you see in the lateral view, sometimes it's ellipse or circle, depende. And the most important is that this is along the different axes que see. So this shape, this equation for the paraboloid is along the z-axis. similar to this. Look, in this equation you see x is squared 4, no? And they put the box here as an arbitrary number. 4x squared plus y squared, que es 1, is equal to 6. O sea, C es linear, x squared and y squared is quadratic. Therefore, it's a paraboloid, by the way, elliptical paraboloid, because this is ellipse. See, this number is the same, 4, 4, 1, 1, entonces circular, paraboloid. And look at this. This is also paraboloid, pero paraboloid along the x-axis because the x is linear, right? Oh, it's easy identification. And this is paraboloid also, but along the y-axis, because remember the y-axis in GeoGebra is the green color. I forgot to say something here. Okay, in this case, look. Hyperboloid, one sheet. You see que every variable is square, pero one es negative. Entonces es the hyperboloid along the z-axis, que es the guy que es negative. So always the guy gets different, es along. It's the same idea for the cylinder. Entonces hyperboloid to sheet. Let me analyze the formulas. Let me make a zoom. I don't know if you see well or no the formulas. Es minus x squared plus, we have two negative. Entonces to cheap, hyperboloid to cheap. Along what axis? The y-axis is different. Look at here. Another view to understand more clear. It's the same equation, but this is two negative, hyperboloid to cheap identification, and the positive gets the different is along the y-axis gets the green color. And the cone, the cone is similar, it's very, very similar to the hyperboloid one sheet, no? But this is too narrow here, entonces forma a cone. Entonces es similar idea, but the identification is we have similar, you have two negative, but the right hand side is 0. When you see the right hand side is 0, it's a cone. Okay? Now, the famous hyperboloid parabolic. What the hell? Hyperboloid parabolic is this. Okay, in this case, I don't see very well. And this is clear because it looks like Pringles. Are you familiar with the Pringle? Pringle is a hyperboloid parabolic. Okay? Is similar to the parabolic, but it's minus. So we have a x squared, y squared, maybe. C is linear. Entonces this is hyperboloid parabolic, but along the z-axis. Okay? Along the z-axis. Okay, let's see example. And immediately we solving that. Okay, identification. Okay, and also study in detail the traces, the intersecting. However, you have GeoGebra, okay, our friend, to understand anything. Example 1. Suppose in the test I give you this example. It is x squared plus 2z squared plus 6x minus az plus 1 equals 0. Here I ask you, what is that? This is cylinder, this is parabolic, this is parabola, paraboloid, hyperboloid, one sheet, two sheet. I have no idea, I'm totally lost. Es el cone. Es el cone porque he said que es 0. No, Emiliano, you are wrong. You are wrong. Okay, entonces now, nobody saw that. A ver. Ajá, okay. Okay. Entonces, what should I do? Well, you complete a square. So you need to express it, the quadric in 3D in standard to understand much better. Because when you compare with the partner. Entonces now, this is crazy. Nobody knows. But I see something important. Do you see que y is missing in this equation? Yes or no? Ajá. Ajá. Entonces, this is important detail. Si y is missing, entonces, what do you suppose que is this? A cylinder. A cylinder. Ah, when the one better was missing a cylinder. For sure. For sure, for sure, for sure. Cylinder, cylinder, cylinder. Okay, pero no, I am lost. I put it complete square. I put x square plus 6x. I put the x separately. Plus a box to complete the square. Plus 2 c squared. I factorization 2, great common factor, minus 4z plus another box equal. In the right hand side, we have -1 plus 2 boxes. Well, it's obvious. It's obvious that the number inside the box, in the first box at least, is 9, no? Is 6 divided by 2 is 3, squared 9. And the second is 4. It's a coincidence because it's 4 divided by 2 is 2, squared is 4. So in the right hand side, you put 9, but you put, be careful, 8. Why 8 and not 4, professor? Because 4 times 2 is 8, right? Remember this 4 que yo introduce artificially. Inside the parentheses, actually, is equivalent not 4, sino 8, because the 4 times 2. And the factorization this is x plus 3 squared plus 2 times c minus 2 squared equal 16, no? Because 17 minus 1, 16. We almost have in standard, no, bueno, in standard right hand side must be 1. Remember conic section, guys. So you divide by 16, 16, 16, and we have x plus 3 squared over 16 plus c minus 2 squared over 8, 16 divided by 2 is equal 1. Nice, 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 nice. Okay, after that, I can see, I suppose that you are familiar with the ellipse. So in the plane x, z, I suppose the y-axis is missing, and therefore is perpendicular to the y-board plane. We have ellipse, no? And by the way, the center of this ellipse is located at the point minus 3,2, no? Remember opposite side. And a, que is the major axis, is 4. We come from that 4, square root 16. And b, que is the minor axis, is 2 radical 2, which is radical 8. Those approximately, doing roughly sketch, well, I put the center is minus 3, bam, 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 minus 3. This is x, and this is z. Y is missing, remember. And 2 positive, 1, 2, boom. This is the center. And our ellipse is 2, approximately that distance is, doesn't matter. This is not important, guys. Now you see in the, but do you understand? Okay, this is the cylinder. So what is the classification of this surface? It's elliptical cylinder, elliptical cylinder. So it's important, first name and last name. What is the first name? Cylinder, because that's the most important. And we have different cylinders. We have parabolic cylinder, circular cylinder, but in this case, elliptical cylinder, suppose. Ajá. Que the center is located at the point negative 3,2. A is 4, B is 2 radical 2. Y es along the y-axis. Do you follow me or no? Do you follow me or no? Do you follow me or no? Good. To show you more for you, I want to open GeoGebra to illustrate very well this idea. Okay, there you go. Let me open. I open anytime because sometimes GeoGebra is frozen. But don't worry, be happy. Let me try. Open. Open, this quadric, example quadric. Oof. Okay. Okay, let me share the screen. Share. Boom. GeoGebra quadric example. Do you see or no? Do you see or no? Do you see or no? Look, in the first example I want to discuss in today, I copy the original. Look. Oh, a cylinder. Look at that. Along the y-axis and the center is located at the famous point. However, by curiosity, I put together both equations. The equation is given at the beginning and the completed square after. Okay, suppose que it's equivalent algebraically 100%. Look, done in green color. Okay, do you understand very well or no? Totally lost, right? Do you understand or no? Come on, guys, answer me. You follow me? I want to complicate this a lot. Danny said, yes, I got it. Okay. 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 I close. Don't save. Okay, I'm come back again to the whiteboard. Let me share whiteboard. Switching to the whiteboard. Let's do the second example. Let's do the second example. Little by little, you understand, guys. I know. Okay, explain one thing is complicated. The teacher need to approach it little by little. And you see some detail, and little by little you formulate the big idea. Okay, suppose this 4x squared minus y squared plus c squared minus ax plus 2y plus 2c plus 3 equals 0. This is general form. Entonces, general form always, it doesn't matter what quadrant is, the right hand side is 0. Always. Now you see, no, ese con. After, when you put in standard elegant, so you understand si ese con. Okay, let me try. Entonces, complete square, you connecting this and this. Remember, the linear term means translation in the surface. We have linear in x and y and z. It's complicated. So I put 4, like a greater common factor, x squared minus 2, x plus box. Okay, I put together the x part. And the y part is minus, entonces es y squared, let me put a parenthesis, minus 2y, that double minus become positive, plus another box. And it is plus c, paréntesis, ahí la paréntesis, c, plus a box. Equal, and this guy, this 3, I move to the right hand side, like a minus 3. What's the problem? It's frozen. Who is frozen? Who is frozen?
Yeah, I also can't see.
Okay. Whiteboard. No. A ver, everyone saw the whiteboard very well?
Oh, it's good now.
It's frozen too.
Oh, it's good now.
Okay, let's try now. Okay, I stop sharing. Yeah, I share it again with the whiteboard. Start. Do you see the whiteboard? Do you see or no? Yes. Plus 3 boxes. Wow. Because I am doing 3 completed squares. Es obvio que the first guy is 1. Actually, in the right hand side, no 1 is 4. Because you have 4 multiplied here. This is again is 1. Wow, everything is 1. Nice. Because it's 2 divided by 2 is 1 square is 1. And this is 1, 1, no? 1, 1. Good. Now factorization. Factorization is 4x minus 1 squared minus y minus 1 squared plus z plus 1 squared. And the right hand side, we have 4 minus 3 is 1. Is wait. Sorry. This is negative 1. Because actually this is negative 1. And negative 1 and positive 1 is cancelled. And 4 minus 3 is 1. Okay, super. I forgot that this guy is negative. So this 1 can introduce artificially here to complete the square. Actually, it's not 1, it's negative 1. Entonces now this moment is ready. Right hand side 1, nice. Okay, entonces this identification is, not sure you got the 3, 1. Okay, no. Actually, the first one is not 1, it's 4. Because you have this multiplier. The 1 times 4 is 4. This is this 4. Guys, this is called algebra, okay? It's okay? Entonces, identification. What kind of surface it is? This is hyperboloid. 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 One sheet. How do you know que es one sheet? Because we have only one negative sign. And the center of the hyperboloid is located at the point 1, 1, negative 1. Okay, this is 1, 1. Remember in the equation, when you see negative in the point is positive, no opposite sign. A is 1/2. B is equal C is equal 1. Because it's 1/4. Square root is 1/2. And along, this is the most important detail, along the y-axis, because the y-axis is the variable is negative in the equation. Do you see or no? So it look like that. Bim, bam, bam. It's a y-axis. Hyperboloid 1G look like that. Okay. Good or no good? Let's see in your algebra to understand if we are doing well or no. I suppose you have infinity question, guys. This is a moment to ask me. Okay?
Professor. I was curious if the right-hand side is always positive for the hyperboloid 1 and 2 sheet.
Well, good question. When you express it in standard, mister, the right-hand side always is 1. Suppose que es negative 4 or negative something. You multiply, but you divide by negative something. Entonces, the most important clue of the identification of this surface is que in the left-hand side, we have 2 positive and 1 negative. That is the reason que hyperboloid 1 sheet. And the right-hand side, you need to manipulate algebraically to guarantee positive one, always.
So once you get it in standard form, it's always positive one.
Exactly. So I give you in general for crazy, confusing, nobody understand this. I organize smart, and so now I separate the X, I separate the Y, I separate the Z, complete the square. And it doesn't matter the coefficients that you have on the right hand side, you divide by this number because I need to guarantee positive one. And nice. And you say now, stop. Too much work. Now, how many negative? Only one. A hyperboloid one sheet. Along what axis? Along the white axis, because the guy gets negative. Right? More clear now? I understand it gets hard. Well, not hard, but it's too many details. Let's move on to.
So how do you know what axis it goes along?
Good question. In this case, look, we have something X plus something Y plus something Z. Yeah, it's supposed to be one here. The guy gets negative. Negative here, positive here, and positive here. So this is the clue the given gets along the y-axis because this negative. It's a positive and it's a positive. Super?
Yeah, so then for the two sheet, how do you know what axis it's along?
Okay, two sheet is, look, x squared. This is the thing I want to discuss, guy. Look, c squared. The number here, and number here, plus, and this is 1 because I guarantee standard, no? And this is supposed to get negative. This is positive, and this is negative. Entonces es 2 negative indicate hyperboloid 2 sheet. I promise I bring example to illustrate this. You anticipate a little bit. And along the y-axis again, because the y-axis is the axis is different.
Oh, okay.
Okay. Good. Little by little, Mr.
And just one last question for the ellipsoid, the coefficient on the right hand side, it's always positive.
Always positive. When you see this is positive, this is positive, and this is positive, it's an ellipsoid.
And then the right hand side will also be positive 1 in standard form, or not the 1.
Exactly. Yes. 3 yes. Okay.
So it is positive 1 in standard form.
Yeah. Of course, standard form is extremely important to analyze. Let's move on. Okay, I deviate a little bit the discussion, but it was good. I want to see the famous hyperboloid, you know, that one, no? And GeoGebra. Okay, good. Let me try. Try. Okay, GeoGebra. Same folder. I want to, when I send the video, I will send this GeoGebra script. And you can see, and you can analyze. It's a copy. Okay, not example 1 anymore. Example 2, look, bang! Look at example 2. This is the famous, sorry. Let me share the screen. Oh, we forgot this. Okay, what? Do you see the GeoGebra? Do you see the, now, yes. I copy both way. I copy the way it gets given. Yeah, I copy the after the completed square some standard. Bang. Green. It's the same. Look. It's the same. Let me flash it. Green and red. Do you see? And the center is the point you determine is 1, -1. More clear? Okay, more clear or no? Answer me, please. Okay. So now I propose you stop. We continue working too hard with the. Oh, let me see. Stop sharing. Do you see my face now? Okay, entonces I propose you continue. Next class. Esto is another example. You see hyperboloid to sheet, you see cone, you see parabolic, hyperbolic parabolic. And we discussing in detail, for example, doing the graphic, not necessarily using GeoGebra, using intersecting and traces. What is traces? Traces is, for example, you have ellipsoid. Ellipsoid look like the football ball, no? And you are doing tracing. Tracing is you are doing arbitrary plane, and the plane cut off the surface, and you see in the intersection between the surface and the plane, you see the conic section gets formed. Okay, along the surface. This is the idea for the next class. So we continue. I have 4 more problems of the completed square because you need to be familiar. I know that you know that part, but it's given in general. You convert to a standard, you determine the center, you plug in GeoGebra, but I want to show you more without GeoGebra, how you analyze this. Okay? Super good. Have a nice day. Friday, don't forget Friday. Friday is an important day, super important day.
Thank you.
Bye-bye.